everyone. Welcome back to another great section of this wonderful tutorial class. Today, we're going to be looking at the dot product of a vector. Dot product of a vector. Please ensure you watch this video to the end. Don't skip any part of this video. Don't skip any part of this video, and ensure you subscribe to our channel. Very important. We have other videos on vectors like scalar addition or suppression of vectors, that is vector algebra. We have the parallel law of vectors. Please, you can look at those videos if you have not done so. And please don't skip any part of this particular video. This is Best Academy. We are highly interested in your academic success. Please ensure you follow us to the end of this video in order to understand this dot product in details. So please, what is dot product? What is the meaning of dot product? What is the meaning of dot product? A dot product or scalar product of a vector. So either you call this one a dot product or you call it scalar product. That's another way to call it scalar product. Scalar product. So the scalar product or dot product of a vector is the way of multiplying two vector quantities in order to have an answer that becomes a scalar quantity. So when we multiply two vector quantities to get a scalar quantity, we call such multiplication scalar multiplication or dot product. Remember, product mathematics means multiplication. And we can remember that. So the scalar product or the dot product of two vectors A and B is defined mathematically as follows: as A dot B equal to the magnitude of A times the magnitude of B cos theta, where A and B are vectors. A and B are vectors. And this scalar product has its properties. It has its properties. For example, let's have some properties of scalar product. From properties of scalar product. For example, we have unit vector I, J, and K. We have unit vectors I, J, and K. Now, the scalar product of the same unit vector will be equal to 1, while that of different unit vector will be equal to 0. For example, let's say we have this something like this. I dot I to be equal to 1. J dot J will be equal to 1. K dot K will also be equal to 1. Take note of that. Take note of that. Then you have I dot J to be equal to 0. J dot K also equal to 0. K dot I will also be equal to 0. Take note of this. Very, very, very important. Very, very important. Then scalar product is commutative. Scalar product is commutative. That is A dot B is same thing as B dot A. Take note of that. It's very, very important. It's very, very important. And we also have different and so on applications. We have other properties. Now, let's look at applications because of time. Look at applications of scalar product. How to apply this scalar product. Now, number one, we can use scalar product to check if two vectors are perpendicular. For non-zero perpendicular vectors, there are applications now. Applications of scalar product. Now, if two vectors are not zero, let's say they are having values that is not equal to 0, their scalar product will be equal to 0 if both of them are perpendicular. If two vectors are perpendicular, if the angle between them is 90 degrees, cos 90 0, if 0 multiplied anything here, we will have 0. So A dot B will be equal to 0. Take note of that. If A and B, two perpendicular vectors, their dot product will be 0. Then, so we can use scalar products. One of the applications is that we use scalar product to check if two vectors are perpendicular. We use scalar product to check if two vectors are perpendicular. So this is one of the properties of scalar product, that A dot B will be 0 if A and B are what? Perpendicular. So from application now or uses, we now use it to check. We use this dot product to check if two vectors are perpendicular. And when two vectors are perpendicular, their scalar product will be what? 0. Take note of that one. Very, very important. Very, very important. Then, number 2, we also use scalar product to solve for angles between two vectors. Angles between two vectors. The angle between two vectors will be equal to the cos or arc, so that is cos inverse or arc cos of A dot B divided by the magnitude of A times the magnitude of B. Also use scalar product to calculate the angle, which is theta, angle theta, between two vectors A and B. Scalar product to do that. Then we also use scalar product to check for the projection of a vector in the direction of another vector, or the component of a vector in the direction of another vector. For example, now, if they ask you what is the projection of A in the direction of B, to find the projection of A in the direction of B, we use, if I say find the projection of A in the direction of B, we will give this one as will be equal to projection of A in the direction of B will be equal to in direction B. In direction B will be equal to A dot B over the magnitude of B. Think of that. So the projection of A in direction B will be equal to A dot B over the magnitude of B. The projection of B in direction A will be A dot B also, or B dot A, that's the same thing, all over the magnitude of A. So the one of B in this denominator will be the one that has the direction, and the direction of that particular vector that is having the direction will be the one in the denominator. So think of that one. We use scalar product to check. We use scalar product to check or to solve for work done. To solve for work done. We use scalar product to solve for work done. Work done will be equal to F dot D. F dot D, where D is displacement or distance moving in a specific direction. When the direction of that distance is known, we call it displacement. The F is force. Then we also use scalar product to solve for power, which is F dot V. F dot V. So we also use scalar product to solve for power. I give you, let's say, I give you force. I also give you velocity. Ask for the power, then the power will be force dot velocity. Force dot velocity. Think about that. These two are vectors. So vectors, and these should be vectors. Because you have directions. Think about that. So very, very important. And so on. And so on. So we have other applications that we will be looking at in this place. So these are the applications we're looking at in this section. Then please, let's look at some typical or good examples now under what you have explained since, so that you understand the topic properly. So let's look at some examples now. Alright, example 1. If vector A is equal to I minus 2j plus 2k, and vector B equal to 3I plus j minus 4k, find A dot B, the magnitude of A, the magnitude of B, then number question, the projection of A in direction B. Then number C, angle between vector A and B. Angle between vector A and B. Challenge time, question A. So you look for A dot B. Now how are we going to look for A dot B? What is vector A? Vector A is I, then minus 2j plus 2k dot, what is vector B? 3I plus j minus 4k. That is vector B. The next thing we're going to do now will be, let's check on the dot product now. This dot dates. So we're going to do it. Remember, the dot product of different unit vector will be 0. Because of that, we're going to dot I to I, we'll dot j to j, and we'll dot k to k. That's how we're going to do it. We'll dot our I to I, j to j, and we're going to dot the k side. So if we do that, we're going to have, now, What is the coefficient of this I? Now, any number that have a coefficient is having a coefficient that is equal to 1. So there's imaginary 1 here. Then, the same thing with this, there's imaginary 1 here as well. But if you want to write the number, we don't need to put them. So the first thing we will multiply their coefficients. Then we will now dot the unit vectors. Remember, I, J, K are the unit vectors we have there. So let's multiply the coefficients now. 1 times 3. Coefficient of this I is 1. Coefficient of this I is 3. 1 times 3. That will give us 3. Then I dot I will give us 1. Can you remember that? I dot I is equal to 1. I explained that before. Then minus 2 times 1. That is minus 2. Minus 2 times 1 is minus 2. Then J dot J will give us 1. Plus 2 times minus 4. That will give us minus 8. Plus 2 times minus 4 will give us minus 8. K dot K will give us 1. So we're going to be having 3 times 1, 3. 2 times 1, 2. 8 times 1, 8. When you dot vectors, the unit vectors will leave, only their coefficient multiplication will be there. So if you want to dot two vectors now, just multiply their coefficients, that is all. And forget about the unit vector at the back or at the front of them. But ensure you multiply I to the I, J to the J, and K to the K side. So if I'm doing this, I'm going to have 3 minus 2, that is 1. 1 minus 8, that gives us minus 7. That will be the A dot B. I'm going to have. Then, question B. Question B is, what is the magnitude of A? Now look at the magnitude of the vector, or the size of the vector. The magnitude of A means we should take the square root of the coefficient of I square plus coefficient of J square plus coefficient of K square. So we're going to have what coefficient of I? I told you we have imaginary 1 here. That would be 1 square. Then plus what coefficient of J? Minus 2 square plus. Don't have this plus, so you must be plus. Since you are looking for the sign between them must be plus. Then what coefficient of K? That is 2 square. Don't take the unit vector, just take the coefficient. Coefficient of this one is 1. So take this one, square it, plus take this minus 2, square it, plus take this 2, and you square it. Then I'm going to have the square root of 1 square is 1, plus minus 2 square give us 2. The minus sign will give us 4. The minus sign will go, because a negative number raised to our even number will be positive. I've explained that before, some of our videos. Then plus 2 square be 4. Then we're going to have the square root of 4 plus 4, 8, plus 9, 9 is equal to 3. So the magnitude of A is equal to 3. The magnitude of A is equal to 3, take note of that. So if you check very well, you saw that at the end of the day, everything is still plus. So if you are looking for the magnitude of the vector, there's no need of taking negative sign inside this square root. Just take everything as positive. Because at the end of the day, everything is still positive, so that you don't make mistakes. So look at what I'm trying to tell you now. Number question C here. Question C is what is the magnitude of B? So you are free to do it this way. Just say the magnitude of B will be equal to what is the of I? 3 square it plus not because this plus coefficient of J is 1. Anywhere that have any coefficient is 1. Then 1 square it plus coefficient of K minus 4. Take 4 and square it. There's no need of picking minus sign. You still get the same answer. You still get the same answer. So just take coefficient of this one square plus coefficient of this one square plus even though it's minus, so coefficient of this one square, when I look for magnitude, you still get the answer. Or you just take minus 4, then make sure you bracket it. If you want to take minus 4, you bracket everything before you square it. You still get the same thing. Don't make mistakes. So this one will give you 3 square give us 9, 1 square give us 1, 4 square give us 16. Then we're going to have square root of 1 plus 9 is 10 plus 16 is 26. That will be root 26. and we root 26. 26. So when magnitude of B is 26, then the other thing we can do again, right? The question D is projection of A on the direction of B. So that will be equal to projection of A in the direction of B will be equal to A dot B over the magnitude of B. If I ask the projection of B in the direction of A will be A dot B over the magnitude of A. So this direction will be the denominator. I've already explained that. So that will be equal to A dot B. We solve for A dot B, we got minus 7 for A dot B. Then the magnitude of B we solve, we got root 26. So that gives us minus 7 root 26 divided by root 26. So that's going to have. Then question E. Question E is angle between vector A and B. Angle between vector A and B. So what is the angle between vector A and B? It's an angle between two vectors theta is equals to, you dot them, like the first thing is cos inverse. Remember that? The cos inverse of the dot the 2 divided by the magnitude of the first one times the magnitude of the second one. This is how to find angle between two vectors. Now the cos inverse of A dot B we solve A dot B there and we got minus 7 over the magnitude of A we solved, we got 3, and the magnitude of B we solved is what? Root 26. 26. That will be the cos inverse of minus 7 over 2 root 26. So what is the cos inverse of minus 7 over 3 root 26? What is the cos inverse of minus 7 over 3 root 26? So we do this from your partial calculator. Let's see what we're going to have. Do that from the partial calculator. Let's see the angles we're going to have. Alright, to do that, we're going to have approximately 117 degrees as your answer. So then I click on this, or you convert it onto decimal. Click your cos inverse of minus 0.4576. Cos inverse of minus 7 over 3 root 6. You will have 117 degree. So let's look at some other questions, just few more questions before we go. So let's say some other applications I haven't actually worked on the rest. Let's see what we are going to have. Let's see what we are going to have. So you can take this question down. Take this question down. Calculate the work done. Calculate the work done. Are you there? Calculate the work done. When a force of F equal to 4I plus 3J minus 2K. When a force of F equal to 4I plus 3J minus 2K. When a force of F 4I minus equals 3J minus 2K is in newtons. Move a displacement or distance. You know, when a distance has direction, we call it displacement. When distance is going to have direction, move displacement of 3I plus 9J minus 6K. 3I minus plus, let's see, 4J minus 6K. Move the displacement of meters. With the displacement of 3I plus 4J minus 6K. I've already worked on the force of this, move the displacement of this in direction of this force. The work done, solution said, work done is equals to F dot what? Dot D. F dot D. So this will give us what is F? 4I plus 3J plus 2K dot what is the displacement 3I plus 4J plus 6K plus 6K. So again, you want to dot I to I, J to J, K to K. So we don't multiply only that coefficient, that's all. If you dot I becomes what? It become 1. So 4 times 3, that will give us, let's do this to this, this to this, this to this. 4 times 3 is 12. Then plus 3 times 4 is also 12. Minus times minus plus 2 times 6 is also 12. So 12 plus 12, 24, plus 12 again, 36 newtons meters. Or you say 36 joules. So that's going to be the answer. So you call it newton meters, or you put it in joules. That will be the answer to that question. Now let's look at this other question. Obtain the power developed. Obtain the power developed. Obtain the power developed in an engine. An engine which applies a force of I plus 2J minus K, which applies a force of I in newtons. I plus 2J minus K runs in velocity, velocity 3I minus J plus 2K minus 2K. 3I minus J plus 2K meter per second. So take the power developed engine, it uses this force to run its velocity. So let's look at the power development now. Solution. Remember I told you power is equal to what? F dot V. That would be, what is F? R plus 2J minus K dot, what is V? 3R minus J plus 2K. So if you want to dot only that, remember, take the V1. So it's only 1. So 1 times 3 times 3 plus 2 times minus 1 that's minus 2 minus 1 again that 3 minus times minus plus 1 times 2 that's 2. So 3 minus 1 2 that's 1 plus 2 and 3 joules per Newton meter per second, or 3 joules per second, or 3 watts. That will be the power developed in that engine, 3 watts. Then let's get another question. There's another question. Now we know that we have done this stuff in decades. So let's get another question. What must be the value of A? What must be the value of A? What must be the value of A? For these vectors, A equal to 3I plus AJ minus 2K, and B equal to 6I plus 3J plus AK. What must be the value of A for these two vectors to be perpendicular? What should be the value of A for these two vectors to be what? Perpendicular. So remember I told you guys For two vectors to be perpendicular, what happens? They are dot products. That's A dot B multiplied to what? 0. You dot them, they will go to 0. So that means our A, which is 3I plus AJ plus 2K, and dot B is 6I plus 3J plus AK must be equal to 0 for these two vectors to be what? Perpendicular. That's the meaning. That's why that particular is there. That means if you dot them, they will be equal to 0. So let's dot. Just multiply the coefficient to it. 3 times 6. That is equals to 18. A times 3. I'll give us 3A. A times 3 is 3A. Remember, I to I, J to J, K to K. Then 2A, that is 2 times A, and give us 2A, is equal to 0. It's equal to 0. It's equal to 0. The next, our 18, okay, 3A plus 2A will become to 5A, to the 5A equal to 0. Then, to move this 18 to this other side, 5A will be equal to minus 18. Then, if I go side by 5, which is the version of this A, so I'll cancel this. Because if I go side by 5, 5 will cancel 5, only A will be here. But we are looking for A. Minus 18 over 5. Minus 18 over 5. So let's try this one more. Calculate A dot B. Calculate A dot B if vector A is equals to 6J plus K and vector B is equals to 7I. If vector is equal to 6J plus K and vector B is equal to 7I, what will be A dot B? What is going to be A dot B? What is going to be A dot B? So for us to do this, it will be very nice to write everything in full so that everything will have ijk here. So both here will have ijk vectors. So we will write A, I write vector A as, since there's no I here, we will put 0I plus 6J plus K. Then vector B will be 7I, but there's no J and K, we put 0 for J plus 0J plus 0K. So our A dot B will be, A dot B now will be 0R plus 6J plus K dot 7R plus 0J plus 0K. So A dot B will be A 0 times 7, that is 0. 6 times 0, that is 0. That is 1 times 0, that will also be 0. So this coefficient and this coefficient is 0. Remember I to I, J to J, K to K. So 0 times 7, 0. 6 times 0, 0. And 1 times 0, 0. So the A dot B will be 0. The answer for A dot B there is 0. So take note of that. It's very, very important. Now, find the value of A. Solve this one as classwork. Find the value of A. Find the value of A. Find the value of A. For these two vectors to be perpendicular. Find the value of A for these two vectors. A equal to AI plus J plus 3K. Then B equal to 3R plus 2J minus 3, let's say plus 3K. Plus 3K. Let us say plus AK. Plus AK. So find the value of A for these vectors to be perpendicular. Find the value of A for these two vectors to be what? To be perpendicular. So I would like to change this on to 9G. So the vector will be AI plus 9J plus 3K, then the will be 3R plus 2J plus AK. So what will be the value of A? For the two vectors to be perpendicular. So solve this one on your own. So this will be the first one. Then the second one we also solve on your own will be find A dot B. Find A dot B if vector A is equals to 3R and vector B is equals to 9K. So what will be A dot B? What will be A dot B? So if you do this very well, you're going to have to do it on your own. Try to see if you get the answer. So if you do it very well, you're going to have 0 for this. This will be the answer to this. This will give you minus 3. So try to see if you can solve these two on classwork. And in our next class, we're looking at vector products. So God bless you. See you guys in our next class. Thank you.